So we have, today, we have our, alumni, Mridul Jain, who would be talking about a very interesting, domain of design of a, design of a cook stove. And Mridul, if time permits, you must show us your P2 project also later on, where you designed the, cook stove in a modern context. Also, after this presentation, maybe that you don't need much present time for that. So maybe you can take a 5-minute break and present that also, so we get a real contrast of research-based learning of form and uh, how we went about doing this. So first, we'll start with this presentation. So Mridul, are you online?
Yes, sir.
Yeah.
I'll show this project which is happening in Chennai. So this is a simple solar-based cook stove, but I'll show you how the project started and how the need arose. So you are seeing these images from regular Indian rural villages. So everybody of you might have seen that they use these mud chulhas and they use wood and cow dung as the fuel source. So it has its own advantages and disadvantages, but the design, it has become obsolete because we have now solar panels and electricity. So it has its own disadvantages, as we all know, like it is a very polluting fuel of indoor home pollution, and there is a risk of fire hazard. And but it has its own advantages also, because it is quite functional if you see their local practices and how they cook, and it can accommodate a number of vessels, large size, small size, and and the system cost almost nothing because they use their vernacular uh, constructing techniques and methods, and mud costs nothing. So, and also mud is a excellent insulation when it is used in a thick form. It provides excellent insulation. So then we went about thinking that how can electricity can replace their cooking system, because right now they cook on a flame-based, fire-based system. So the need was that many of these villages, they are lie in very remote areas where there is not electricity grid, and even if there is, the supply is very erratic. And also because we have our country in, we have ample amount of sunshine, so why not use it? So but solar panel system usually require a battery and inverter. So because right now their cooking method, their cooking mud cook stove almost costs nothing. But if they install a solar cooking system, they have to invest in an expensive battery and inverter system apart from the cook stove itself and panels. So it is a very expensive system. So we thought of eliminating this battery and inverter unit and just creating a simple kit, very cheap kit, which they can just install in their houses and start cooking. So it has its advantages and disadvantages, but we were trying to create a cheap source because it has its own disadvantages, because you cannot cook during night, or many a times when sunshine is not there, cloudy sky conditions, then you would not be able to cook. So then we went about thinking how to approach it. So like actually there are also, apart from once cook stoves you are seeing on your screen, there are, there are many types of solar cookers, parabolic and mirrored and box type, but they have their own disadvantages. Like they are not very convenient for local cooking methods, and you have to go out of the house to cook, and you cannot cook during night times, you cannot control the heat. So, and then there are these electric hot plates, we all have seen them. So they are also of different wattage, like this is 200 watt, this is 1500, 1000 and 1000. So they are basically nichrome wire, and they are either encased in ceramic coil, as you can see in the second picture, or they are insulated in terracotta or ceramic, so that you would not get shock or current, because direct touching would make the make the vessel also very hot, and it can also create shock conditions. So, but all these stoves are AC stoves, they are not DC stove. So also inverter and battery, what does it also converts AC current into DC current. So, but now we cannot rely on these coils because they are designed such that their resistance is more suitable for alternating current. So now we have to design our system, we have to design our coil also, which can work on direct current. So then we went about technically seeing how the system would work. So theoretically, the resistance of this panel, solar panel configuration should match the resisting of heating coil. So the panel range available in the market is 40 to 400 watt, and heating coils, as you saw, 1000 to 2000 watt, and even more there are available. So our challenge was to get a consistent current supply because we are not using an inverter and battery. And user safety is also very important, because when you are not using inverter and battery, then sometime amperage and voltage can get much higher, which is also very lethal. So as you can see, these are four formulas of calculating current and resistance. So basic calculations are done using these basic formulas, but then testing on the site, testing according to sky conditions, and there are also many variables. So the final results don't actually match their theoretical results, but the theoretical formulas are where we start. So as you can see, these current formulas. So the coil pictures you are seeing, these are the coils which we ordered, are custom made coils. So there are 2 or 3 variables which will affect the resistance of the coil. As you can see, this last formula, resistance is equals to rho into length by cross section area. So rho is a constant. It's the property of the element, the nichrome, and length. So the resistance is directly proportional to the length of the coil, total length, and inversely proportional to the cross section area. So varying these two parameters, you can vary the resistance of the coil. So you can get your own resistance made. So then we went about doing how to approach design. So as I started with showing you mud chulhas. So they have their flame wala system. So it's directly the flames directly in contact with the vessel. So it's heat transfer by conduction, and also it's also through radiation, because fire is directly touching the vessel. So, but when we use electric hot plate, the flat plate, which I shown you, so they are not very suitable for our Indian vessels, because we have rounded vessels, and also the contact area will be very less for efficient heat transfer by conduction. In the third diagram, you can see if we create a closed volume around the vessel, so vessel is touching the coil also, but a closed volume is created beneath the vessel. So what happens that the heat current flows in the insulated air gap, which is called heat transfer by convection. So the air is heated, and then the air transfers the heat to the vessel. So it is also a very efficient system if the gap is very well insulated and there are no gaps to escape the heat. So if we create a closed volume, then it is also a very efficient method of transfer of heat. So such you can see all the points. So we have to take care of the shape and size of the vessels we are using, the time they usually take to cook, and easy to use, easy to move the cook stove as well. Safety, cheap, because right now their stove is costing almost nothing. So we have to make it cheap. And if it could be manufactured by local artisans and resources, it would be very good. So like if we can just give them a set of panels and our own coil, and if they can create their own cook stove, that would be also a very good system. So this is the first concept which we made. So it's a basic pot, the gamla, which is available in the market. So we took this form as a starting form and put the our coil inside it. So what happens, you can use it through conduction cooking, like you can just keep the vessel above the coil. And if the vessel is big, then the vessel can sit around the rim of the pot, and the internal volume is insulated, and it's a closed volume, so convection heating can also happen, or you can just keep it directly above the coil. So then we made renders and prototypes, and like it's a quick prototype, working prototype testing rig, and we started doing testing. So the coil and stove were being developed simultaneously, so that the technology wala part is also going on the solar panel and coil thing, and our design is also simultaneously going on. So then this is concept 2. So this is based on, it consists of 2 parts, and so I'll show you the renders. So as you can see, this part and this part. So you can use it directly as a conduction cooktop, and also you can use this part in two ways, like this also and this also. So what happens when you are using it in this configuration, then this acts as a convection oven kind of thing, a normal cooktop conduction, cooking through convection if the vessel is bigger, and it can also sit on the interior rim, or you can just use it if the vessel is like the intermediate width, then it can also sit between, and then this convection cooking can happen here. So again, we made renders and quick prototypes, and Rick started testing it. Then this is the design which is in its current form. So when we realized that terracotta is unlike any other industrial material, like it shrinks when it dries and you bake it, and it's not very precise. So our concept, the concept which was based majorly on the convection cooking, would not be very feasible, because there will always be gaps and inconsistencies where heat can leak. And also our initial prototypes which were being made, the mud cook stove, mud chulhas are very thick, like they are made of very thick layer of mud, like 2 to 3 inch thick. And in our terracotta layer was only like 1 inch thick. So the heat was still leaking. So right now, what we have made, we have designed a double layered terracotta stove. So this, which has a layer in between, a layer of air, so which will increase the insulation capacities more. And also we are also making multiple models to check what height would be suitable, so that convection can also happen and conduction can also happen efficiently.
So students, again, very interesting, domain of how we looked at the product from a, point of view of both sustainable production and, looking at, how the product can also work much better than any of the other, other products, because of that, insulation the terracotta provides. And that's the reason why I want to show you, because our also focus for the course this time was the products in our house, the kitchen products in our house. And the kitchen products, our want to introduce you to kitchen products in the house, where we're going to bring in all our learning from our semester into the last semester, of course, and the and the new inputs we get to work on the kitchen products. We select whatever we have in the house, so we have a context and we start working on them. It could be regular sort of regular mixer grinder, or it could be regular utensils. I think we'll stick to utensils in the house which we use regularly, and and then we look at those products very closely as our theme for the session of this module. So any other points, students, both critic and discussion, most welcome.
Sir, I was thinking, yeah, like the terracotta, the pot that was like made, what, like was it made like hand by hand or like pottery wheels, or it is like made in some other way? Because the module that has to fit inside the terracotta pot is like accurate in measurements, but how that a potter now can make it very accurate? That I was thinking.
Very, very, very good question. So what we did is we left a lot of tolerance. So that pot is made by hand. We have a very good potter who comes to IDC for giving lecture for showcasing demos also. And we went to him in Dharavi. Dharavi, there's a huge cluster in Bombay who make pots, large pots, and then they also are very now good in tolerancing. So we have large tolerance. See, for example, this doesn't need very close tolerancing because our internal component is pretty to fix, but we can leave enough gap around it, so it was not at all a challenge that way. So it is made through hand process completely, and and fired also at the potter's end. And our future idea was that we will send only the coil and the electronics, and the craftsmen can make the pots.
Okay.
So that was the future goal, where you just give some dimensions and the pots can be done locally. In fact, this again, the everlasting credit of Professor, the Gopinath Rao, who was our teacher, in IDC. He would always say that look at the watches in the market. The mechanism is just 45 rupees, whereas the watch outside can go to enough variation. I'm not talking about money. I'm talking about the form and the expression.
Yes.
The quartz mechanism is just 45. That's the heart, right, of the watch, the quartz mechanism. And that doesn't cost anything now.
Right.
It is finally the customization and what type of perception people. So similarly, if you have this high-tech, nichrome coil, fixture, and then you could have any envelope around it, and that envelope can be made locally. So the transportation is easy. Everything is possible. Yeah. Go ahead, Mridul. You want to show some images?
So these are the prototypes which we made. So this is the unit on which the coil will go. So as you can see, we have made these electric connections, and also we have put glass wool beneath to decrease the loss of heat from beneath. So that's how the coil. So right now this coil is very like crooked looking because we gave a order of small numbers. So once you give a large number order, then the coil can look much better because they can make their own rigging. So this is the final pot, the last prototype. So the next prototype will be a thicker double walled pot, which will be on the same, and also a lid cover also. So these are just prototype images, stage prototypes. This was the older than which I shown. Yes, sir. Absolutely.
The steel model with the coil is what will be sent to people, and the pots.
So that could be a thing, because if a pot is easy to make and people can make the pot locally itself, then like we have to see it still. I'm not sure how this model will work. This can be a possibility.
What is the wattage?
The coil is 1000 watt, because without battery and inverter, we cannot afford higher wattage coil. So basic 4-panel configuration with a 1000 watt coil.
So it's a direct connection.
There are other small components there are also people from energy sciences department involved, which are looking at the technical part of the project. So, but majorly panels and coils are the two main components.
One more, while we are talking about this, Mridul, we would like to see students again. We're talking about tiredness of perception and training of perception. But you saw this product because this product is specifically for people who want to save their gas. Because even though gas cylinders have been provided, people are not able to buy the gas because 1,000 rupees is the one cylinder. And our product cost, the unit will just cost as low, including the panels, at 4,500. So just 5-cylinder cost, you're able to get your stove. And so it is for that segment which is not able to afford. So our design is for that segment, right? So that's very interesting. So now look at the other segment which Mridul did as his P2 project. Mridul, you have your P2 presentation available online somewhere? You can download and
Yes,
show?
sir. I'll take 5-10 minutes. I'll find it.
Yeah. We'll take a break and we'll, while I'll discuss with students, you can bring your presentation. So you could show that also as a paradigm shift of understanding, like even with sustainable technologies, we have to go with the aspirations of the user in mind, whichever user is the most critical user for us. So Unform is, part and parcel of, the journey. So any other, and Mridul, you could leave your images on if you want, that the image folder. Yeah. You've seen. Please let us discuss that, students. Yeah, one by one. Yeah, sure.
Sir, actually, I had one question regarding the manufacturing of pot. So it is made of terracotta. So can we make it through centrifugal casting by making it more fluidy, the mud? And then is it possible if it can be manufactured that way?
Yeah, they do slip casting. I'm not sure about centrifugal, but it will become too expensive unnecessarily. Slip casting is a very simple technique. No, they do that regularly for all your commodes in the house, the ceramic commodes. No, all those are done by slip casting. So this can also be done by slip casting.
Okay.
In mass production, you have no choice. You will have to go for slip casting but then if you do distributed production, then it can still be terracotta, original. You can find some local. See, today the whole thing is about distribution. So you can find a local potter. You can have deal with him. The person who is distributing in the village can get the pots sourced. It's easy to source locally. All that. But as you rightly said, it's a very it's a very simple process. So see, your form also is part of your part of your distribution channel, right? My pot, if it goes through distribution channel, if it's made in Bombay or it's made in Madras and goes to Calcutta, just imagine the cost, right? It's impossible to handle it, right? So it has to be done locally. My other unit, which is small, can go wherever it has to go as a central production. Yeah, does it answer your question?
Yes, sir. Yes, sir.
Yeah. Anybody else?
I haven't seen any terracotta chulas, or maybe I haven't seen many chulas, but then whatever I have come across are generally cow dung cakes, and they put bricks. What I have in my we have here is we have bricks, and then we put the cow dung onto it. Leapna jise kehte.
Very true. Saga, very good question again. Yeah. So what?
Terracotta pots are fine; they're for cooking, but can it act as a cookware? I mean, chulha.
Yeah. Very good question, Sagar. So basically, what happens is, there is a lot of new technologies and new mixes in terracotta, which the potters are innovated on. So our, the current chula has a special composition. It is not the same composition as our pot. Okay. So it is meant for making a chula. It uses a different, level of mix of, silica and other things what they use for, kneading the clay. And some of these technologies, our people know. Instead, the people who do, at that end know. We'll add that in the presentation also, so that next time it will be very clear. But again, excellent question. Because thing in our journey, that depending upon the function, you need to choose the material.
Yeah.
Right? And then it becomes so critical, right? And you've not seen it before. But let me just guess. But people have made, of course, they have coated with mud and clay, and then the lopus internal structure is made out of this. But I've seen terracotta tavas. You've seen tawa? Terracotta tawa?
Yeah, tawa we have. Yeah.
And it is very clear that it can take all the heat, right?
Yeah,
more heat than the body.
Yeah, but it has to. So there's a tawa can come down, but chula goes on. Chula has to sustain a long heat for longer duration. That's why they are more thicker and things like that.
So in fact, this also is more thick, and then on top of it, you saw the top being open. No, and then when the spacers come, we'll have to be very careful about the volume and the the capability. But terracotta is, they fire at 260 degrees and 280 degrees. So basically, they're meant for this purpose. Mud, and you saw the horses, iron horses opposite IIT. Oh, you've not been to IIT, but have you noticed the pictures? Have you seen picture of the horses?
Yes, sir.
Yeah, if you see some of the pictures, so those guys, in fact, it is such a knowledge for us, Sagar, that these guys came all the way from Chennai, and they actually brought in the mud and the mix from Chennai in a truck, and it was a very special composition of the terracotta, which will last for years together on the outside of the house.
Well, that will create a problem if you are planning on making the pot locally, is what I was going to point out.
No, that's what exactly I'm saying. There's a value which each
To
of
give
those
the
potters,
composition.
each of the potters has that understanding. अरे चूल्हा है तो मुझे क्या क्या डालना है?
Probably.
Yeah, lot of knowledge. In fact, there's such good knowledge system available. Unfortunately, we are not able to tap much, but it's going to be that way. Yeah. Okay. Anybody
Maybe
else?
potter here might not know to make that composition which you have.
No, we
made.
can guide them. No.
Yeah,
we can guide them, and we have the templates with us. We have the specifications.
Yeah. Well, that's
so
an
the
extra
distribution
component that has been added into the process. What I was trying to point out.
Yeah.
You have to teach. You have to analyze. Teach the local potters everywhere wherever the chula goes.
Yeah.
Use this
So it's good,
specific
no? It's very good to do that, because you need to also upskill the craftsmen. In fact, today, for example, I showed you the copper bottle. So I've upskilled the copper artisan to solder stainless steel with copper. So we are getting that machine, induction welding machine, induction soldering machine, and we're giving it to the craftsman. So he's doing induction soldering so that the stainless steel and copper can get attached.
Yeah, that was my question about the bottle accelerators of
yeah. So it's like we have
steel
to,
and copper.
Yeah. So we have to build in that type of capabilities.
Exactly.
Yeah. Okay. Any other question? Any question on the form, students?
So actually, I had a question on the form.
Yeah.
It's like a pot. So basically, when we talk about chulhas or something, like just Saga mentioned, that the chulhas are generally fixed, and the layer is adding to the stability of the form, and also for the function, so that even heavy utensil can be used on it. But this has a very limited options of utensils to be used. I cannot use like heavy, huge utensils for cooking. So I need to go for alternative option for that. So this actually limits my use. Like I can use it for only daily purposes, or like small amount of utensils. I cannot go for like bigger pots. So that was my like I had this thing like, okay, the normal chulhas we can like put a small pot to a huge pot. It can go for all the things, but this has a very limited size, and
I think it's pretty large, Shivani. That image looks small, but pot काफी large है. तो वो अगर छोटा रखने के लिए, if you have to make it small, we have to put a spacer. But otherwise, it really takes a very, very huge, thing, and the thickness of the material is pretty large. It's very, very strong. We're not done any study, but it's a very good question what you're asking. And this is an exclusive, sort of stove for doing cooking, while the sun is bright, for your regular cooking. So it is a little bit more premium than our, home built chulas, which are so it's
so like when you just say premium, then it's like an exclusive thing. Like how can it be more of like easily distributed?
Within that context, we are saying it's a product which is like for the next level of, when I say premium, it's not premium. I'm saying that the next level, people graduate to this because you have to spend money for it. Your regular chula, you just put coal and wood, fire and things like that. But this is like the next. In fact, we didn't tell you the inspiration, where we got this inspiration from. So one of our friends, I think students, if you're not on campus, but you should Google this, called Energy Swaraj Yatra. Energy Swaraj, Professor Chetan Solanki, on the YouTube. Energy Swaraj Yatra, Chetan Solanki. He's a colleague from Energy Science. He's resigned from IIT, and he said, I'll travel across the country in a bus, and I would like to promote use of solar energy. So he, so we, in fact, we together built an induction stove using solar energy, and the whole village we put the induction stove, right? So what's the problem with induction stove? Anyone? Induction stove?
It gets up very easily, very quickly, and you can
Ah.
control the heat.
Yeah, but what's the problem? What's the problem?
You can only use flat based utensils.
Flat pieces.
Yeah.
It uses flat blaze. What else? What else?
Power supply.
And only metal that conducts.
Conductor metal, yeah.
Conduct. So yeah, people are not. It's a perception. The training of perception is so much that they don't want to change. And I'm going to give it to I give it to a village. We gave it to a village. The whole village was using it. Okay? That's one story. So then it failed, and they replaced that with nichrome, whatever we used, the regular coil, and now they're using the coil stove. It's like much more inefficient way, but they're using it. Okay, so that's one story. Another village we went. In that village, we found out that they were having this fabulous, what you call fabulous free supply of power for farming. अभी मुझे बोले यार फार्मिंग को फ्री पावर देगा तो मैं घर में यूज नहीं करूंगा, करेंगे ना? When you get free power, you use it wherever it is. So they just bought a regular ceramic plate with a coil, and they placed it inside the regular wood fire area, and they started cooking. And it was very efficient. You understood what I'm saying? They had this regular wooden, whatever, that chula. In the chula, they put this electric stove from the market, just the coil and the ceramic, that plate, and they started using it extensively. And then we found it was very efficient because it had very good insulation around, and it was using convection also. Remember the way Mridul was showing you convection?
Yes.
So basically, so then see, so we have to learn from the people of, what. Of course, I'm not saying it is ethical to do that, but I'm just saying that the principle of using convection, principle of using, the traditional, chulas to do. And of course, till we don't try it out, till we don't make 100 and, put it in the field, we will really not know. But we're going to check that out, and we're going to see how it's going to be, used. But again, Shivani has this fabulous question of, this perception issue. Like we really liked it, but I really don't know whether my customers will like it. The people who actually use it will like it. So we need to do a good survey in the rural areas to find out. That was one question. So Shivani, we don't have an answer for that. Second question she was asking was, will it be able to take large utensils? That 100% will be able to take large utensils because the thickness is pretty large. We've used very, very large sections, and it is fired extensively well. And after firing, the strength is very good, but we've not done any study there. And from form point of view, does it look like a chula, students?
It looks like flower pot.
No.
It looks like a pot.
It's like
It looks like a pot, no?
Yeah, plant
But does it look like a
Yeah.
cooking pot?
no, because we have never seen such a cooking pot before.
So it's
Or gas
completely,
stove.
it is completely out of the, we call it, semantically, it is completely out of the range, right? It's completely new. So when you have a new animal, when you have a new heart and a new body or a new technology, should the new technology come up with a new semantic? But is it creating a new semantic? No, right?
No,
No.
it is
Is
like
it
changing.
those rings and all are not creating a new semantic, no?
No.
Kind of mixing in the same category that is already known to us as flower pot.
Very true, very true. So it is demeaning the current, because you're using high-tech product. You want to have, you also want to make it surely, of course, it should do the function as a chula. So there should be some meaning in that form over there. So basically a lot of work to be done, right? On that point of view, from the form point of view.
I think if it has 3 pivot points, then it will resemble a chula. So
Very good.
any
Very
chula that I've seen, it's circular, and they still do the 3 pointing thing even in a normal.
Very good, very good. So you need to borrow cues from the current products, right?
Yeah, to make
So
them
some cue from the current product. Very, very good point. Some cues from the current product and integrate in the new one, and of course bring in a little bit of little bit of new, because it's a new product altogether. Create a new semantic. What can happen in new semantic? We'll do a quick assignment today later on, where we will see what can this be, what type of, and of course it should be turned, right? It's on the potter's wheel, dear. That's a big challenge, right? It's on the potter's wheel. Of course, I can add 3 prongs over there, but what else can I do on a potter's wheel so that I can, do this. So, I'm going to take you to the studio, after Mridul's lecture. After you do a little bit of reading around 5 o'clock, I'm going to go to the, our ceramic studio with my mobile to show you, some interesting assignments done on pots and, on how the form and pots can work together. In the meanwhile, all of you, please get onto your boards and think from two angles. One is, it is a stove, right? So there's a perception of a stove. And then after Mridul shows you the modern stove, you realize why, Mridul made that new modern stove in a glass plate. Mridul will show you that also. He has done that project, as his endless project. So training of perception, and then of course we're making something new. So, the technology is new. So what new have we to add so that doesn't get confused with the old product? So there's a new product coming in. So that new product has to have new feature, new formal feature, so that you identify with that feature. So between training and tiredness of perception, what will you, and then you have a challenge of manufacturing, turning on the wheel. Very, very big challenge, right? It has to be turned on a wheel. So that's another challenge. So I and Mridul had a little bit of discussion, but we never thought so in depth like the way you taught. And Shivani, very good question on, what do we do with the form of the product? Yeah. Any other questions?
I have a question, more like a discussion. So considering, okay, the form of the product and our user group, will our user group make a purchase depending on the form, and how much is the form affecting the user's perception while buying? Because it's the functionality, like a cooking stove, it should look good. That's all. I mean, I'm not expecting a lot of aesthetic value or form in general. And coming to our user group, they want the functionality. I mean, functionality presides over any kind of form improvement. Is in that direction I was thinking. If I'm telling a user that this is used for cooking and it does the job, and the cost is again a factor, I mean, how much is the form affecting users' perception in this particular case? Is what I wanted to understand.
Yeah, very, very good question again. So in the morning we talked about fashion, right? And Mugdha said 100%, right? Fashion, yeah. You worn a checked shirt, and that's 100% right for you. You like it 100%. So if you go to any product, for example, we are designers, right? So we have got a challenge over here that will it matter? Will it not matter? No. So here, for example, as designers, when we work on it, and then we've seen all of Raymond Louis products, right? Why should there be किसी ने वो select किया copier machine out of your class? You didn't find it at all anywhere, copier machine?
Yeah, we found it, but I don't think anybody chose it.
अच्छा, किसने चूज नहीं किया? वो मेरा फेवरेट था, मेरे को चूज करके मैं आपको बताऊंगा उसका हिस्ट्री. So it had this complete open structure, right? No envelope, there is no meaning. It is just a jumble of wires, jumble of links. Haji, and then the user, it didn't make any difference to the user. वो use कर रहा था, but then he came and he made a meaning out of that jumble, and he created a little bit of detailing. He made some, he covered things which doesn't need to be shown, because all that was giving a lot of clutter. And then when he covered all of that, and designers also, see, we're not saying when you work on form, you don't do anything else. We're not saying that at all. Then you integrate form and function, you integrate form and material, you integrate form and aesthetics, you integrate form and detailing. You have to integrate everything. For example, remember I was showing you the bottle in my room. I don't know whether it's made by Raymond Louis or not, but that bottle had a base, but that base was manufacturing base. That base was supposed to be for a two-part body, but gave a very good, strong base. The width was also large. So, so this is a very standard question where we fight with industry. अरे क्यों फॉर्म चाहिए? ₹1 खर्च करने को तैयार नहीं यार इंडस्ट्री फॉर्म के ऊपर. When I was the same story. So I had to steal form. I had to actually cheat form by making it low cost. Now my petrol pump, the Z-Line petrol pump, which I'm going to have a detailed lecture on Thursday morning with all of you and some NID, Hyderabad students. And they also in the class Thursday, So we're going to have that session. We're going to sort of, understand, the basic, thing, because industry was not ready to accept even 1 rupee more. But then it is not about 1 rupee more. It's about how do you build your overall design? How do you build your materials? How do you put it together? So, for example, that's a terracotta pot. We're saying that it has to have meaning. Yeah, you're designers. You have to create a meaning for the product. You have to have a customization aspect. You have to have a product of differentiation created, right? So we cannot say that we cannot say that how does it matter? It matters a lot. It matters a lot when you look at our traditional products. Traditional products, how they built those traditional products. Every craftsman had a signature of their own when they built those products, and there was a meaning. In fact, very, very abstract, or sometimes very real animals would be adorning some of the products, like the beetle net cutters and traditional products. Like lot of meanings were there. So I think we'll have to be very, very sensitive to that meanings and form. And when we create these products, also most probably when we customize it and when they go to local potters, maybe they'll come up with some of their own improvements, which will be better than ours, because we are thinking from an outside in. They'll be doing an inside out, and they would maybe creating more detailing. They may create more patterns. I don't know. It could be much more different. But again, students of all of you are following very, very serious question on, will that matter? And we are saying that it matters. What you give to the customer matters a lot, and form plays a very, very vital role in that. And whether you're putting any extra money for the form is not a question at all. Car, for example, they don't put any extra money for the form, right? Are they putting any extra money? No. It has to have an envelope, so the envelope is shaped, right?
Correct.
And huge cost. My God, the cost of each tooling they do for those car industry can run into crores. They spend 30-40 crores in tooling of the product, tooling of those shells, which are completely coming out of clay, styling, and then building perception, understanding. Oh, is it looking different? Is it looking same as my other competitor? What differentiation can I create? And that is common for every product of ours, And we have to give, and whether it's a low-cost product or a product for the, product for the, social sector, it doesn't matter at all. It has to have a character. It has to have its presence. It has to have its identity. Very important. We don't even let the issue of cost come in at all here. We will find it out. We'll say that it's integrated design. We'll work out and let you know. But that is the big challenge we are facing. Yeah.
Yes, sir.
Mridul, are you back?
Yes, sir.
So so please, all of you have to be very vigilant, about that aspect of our, form, because we're going to be bombarded by these type of things, a lot when you're building products, and and today that's going to be a very, very big challenge, and we need to understand, how. I'll want to bring in one more very important thing: how the emotive quality of a person. For example, see, you give me something nice. I feel good about it. So there is an emotion which is attached to form, that and there is an aspirational value to form. So are we giving that to the user is a very, very important aspect. The emotive quality, feeling good by having a particular product. If for example somebody doesn't mind, it's okay. But if the people who are not used to that type of thought processes, then we have to make it very, very, we call it honest. But I'm just saying that it's integrated design, so it is a post terracotta. I'm not going to add on something, a new process into it to make it expensive, but we need to do that's very critical. Yeah. Okay, Mridul, please go ahead. Hello. So why I'm saying the next presentation was that's very important what Mridul did, where we used a lot of research data. We used a lot of research data to come up with a completely new product. Here, for example, we have a new product, but at the same time, we are using it, we are leaning too much towards the training of perception and trying to create a glass top next generation cook stove. Again, interplay between training of perception and tiredness of perception. Please have a look at that. And Mridul's done a very, very good job there. And Prakash, please send an email to Sushmita. Sushmita is my different she worked on 8 to 9 years on form and perception as a PhD, and she's in Goregaon. She's an artist. Then she did MDes with us, and then she worked in a software company, and currently she's a visiting faculty at multiple places. And we worked on this very, very exciting project of creating an auto rickshaw. A new generation auto rickshaw for Bajaj Auto. That was a PhD, one of the case studies of a PhD. So like we'll invite her to share her experiences of how we didn't consider even the designer as a person to decide which form to go ahead. We did eye movement recording, and we considered the users, the drivers of the auto rickshaws, people to decide what form should the auto rickshaw have. So that's the level of form perception which is now heading to. So Prakash, please send an email to Sushmita, put it in a draft. I will take care of it. Yeah.
Sure, sir. Yeah.
So like we can anytime during the week, next week, this week, anytime she's convenient. Okay. Thursday, next week. Or next week is a bit still better for us because we'll be into our project.
Sure.
Area. So we'll go ahead with this presentation. Students, after Mridul's presentation, you people please work out on the sketches of our, what do you think? If you were given this assignment of the, terracotta chula, which is, using an nichrome, coil as a base, what would you do? What would your, design be? How will it create this balance between training of perception and tiredness of perception? How will it create a new semantic for a electric chula? It's an electric chula, fine. It's not a wood-fired chula, right? How will you create that semantic? What are the features you will borrow? What are the features you will create new? So let us work on those sketches, and we'll again catch up at what's the time now? I think Mridul will take another half an hour at least for you, and then we'll catch up again maybe at 5:30. Students, 5 o'clock maybe. Is that better? 5:30. Yeah. So Mridul, please go ahead.
Yes, sir. So my P2 project, it's basically another attempt at harnessing sun's energy and storing it and using it for cooking. So as you might have known, like many systems exist, many solar cooker, parabolic cooker exist, but they have their own disadvantages of convenience, and like you cannot cook during the night, and you cannot store the heat. Like in electric coil cook stoves, you can store the heat in battery, or but you cannot store like you can convert the heat energy into electric energy, but you cannot store the heat energy per se. So so this is basically I'm going into that category. So much research has already been done at in IT Bombay Energy Science Department. Many people are working on this thing. So if you want to store heat, so you basically take sun's heat and transfer the heat to another material and keep that in an insulated system, so that you can again extract the heat from that material when you want it. So many materials are there. For example, oils, vegetable oil, rocks, and like you transfer heat to a vegetable oil, it gets heated, you store it in an insulated container, and when you want the heat again, you can again extract it. So basically you can store heat in two type of methods: sensible heat and phase change material. So sensible heat, as I said, oils, rocks, and molten salts. And phase change material, it's a bit complicated. Like if you see, if any of you is from science background, might have known that you have latent heat of vaporization and phase change basically. So you take sun's heat, you transfer the heat to a material, it changes its phase. Like for example, it's in solid phase, it goes from solid to liquid. But when you extract heat from it, then again it goes from liquid to solid. So both sensible heat and phase change both have their pros and cons, as you can see on the screen. So phase change material are very it's still the research, it's in very nascent stage, but it's low weight and storage volume is less. Like you just need a less amount of storage. Like for example, in sensible heat, if you're storing your heat in through vegetable oil, then you would need a large insulated tank to store that much amount of oil. So yeah, I know it's a bit uh, science based, but so when you see pros and cons of both sensible and phase change material, so as you can see, sensible heat phase change material, they have their own pros and cons. So we chose sensible heat and took it forward. So like as I was telling you, this is the basic schematic diagram. So this will be the heat storage tank. We chose vegetable oil as our material. So there are two loops. This is one loop, collector side loop, and this is load side loop. So what happens, there is this solar collector, parabolic trough collector, which concentrates sun's rays and heats up the vegetable oil, which is going in copper pipes. And the heated vegetable oil comes into storage tank, and then it's an insulated tank. You can store it, you can use extract the heat in night even if you want, and then from this storage tank the heat goes to a cooking unit or cook stove, in which the heat get exchanged. So it cook stove is basically the oil is coming in copper tubes. So a cook stove is basically copper coil, like coiled in spiral way, so that it's you can use it as a stove. So I'll show the design ahead. So this is the basic system. So then again, after reading and consulting professors and reading some papers, so there were few technical considerations, like the diameter of the copper transport pipe is exclusive to the system. If you increase the diameter, then heat transfer changes. If you decrease, then the heat transfer changes. As I said, we use oil-based material as a sensible heat storage. For collector loop, the upper side loop, the flow, as I shown you, there are two pumps, like pump 1 and 2. So what they do, they control the flow rate. So if the flow rate is more, then the heat transfer is also more. For example, if the flow rate is more, then the heat transfer between coil and vessel will be more. So, and then there are also major considerations regarding kitchens, because kitchens have very little space, because this will again require some changes in infrastructure, because copper pipes and coil will come to your kitchen from the stove. So this system was designed keeping in mind the urban context. So the idea was that collector loop system will be on your stove, and then the pipelines will come to your kitchen, and then you can exchange the heat from there. So then we went to a few homes, Indian homes, and took a look at their kitchens, how they cook, what they cook, major vessels they use. And so initial ideations were done on, as I mentioned, like it's copper heated oil will come through copper tubes, and then it will go out, and then the cycle continues. So how can you translate it into a system? So initial ideations were based on that. So for example, this is a cross-sectional, copper oil, heated oil can come through copper tubes from here, and then it will go through this system, and anything which is inside, any liquid or anything, will get heated through the heat exchange between copper tube and the liquid, and then the hot oil again goes outside. It can be also translated into this tray kind of system, where oil is coming from here and looping and exiting here, and then you can insert these vessels or specifically built trays, which will in turn cook the food. You can also take the analogy of immersion water heater, like copper oil, heated oil is coming into this coil, and then you insert this system into water thing or your cooking. You can also make rice cooker analogy, where you insert another vessel and under there are copper tubes with heated vegetable oil. A telescopic circular concentrated tube which will take the shape of the vessel bottom curvature. So these are the ideations you can see, like electric sandwich maker wala analogy, where copper tubes are here and then you can keep your chapati or bread maybe. So different analogies and different ideations were done. And so first concept was, so then basic thought was put in the design of the copper coil. So concept one for the coil was, so there will be two connections. So when using a larger vessel, you can just use these interior coils. The oil will only flow in this part. When a bigger vessel, then the whole thing can work. So the idea behind this was because we have to decrease the heat loss and increase the efficiencies. So the part which is not being used should not come in contact with the vessel and vice versa. And concept two was making these joints flexible. So what happens, it becomes a telescopic kind of thing. And as you can see, it's in the cross section, you can take, it will take the shape of the curvature or the bottom of the vessel to increase the contact area between the coil and the vessel. So it's like this is the main consideration, to increase the contact area between the coil and the vessel. So then this is another concept where you design vessels specifically built for this system. So this is a copper coil integrated with the vessel. So you just have to plug it to your copper tubing system in your kitchen, like you plug your stove LPG to the LPG connection line. So each have their own pros and cons. So we evaluated these concepts. So the concept three would require a drastic change in the market for it to be feasible. Concept two and concept one can be are combined and then taken further. So then further, the like before, as you can see, I was twisting the copper pipe like this. So it's also very tough to take these small curvature turns, and it was also taking much area. So instead, I made a spiral system which will have more area and less number of turns, and it's also easy to make. And then solar hop type 2, which has flexible turns, can also be based on the same analogy. So now this is like the technical system. So there is a pump, there are two valves, and there is this tube. So this one knob will control one valve, this another knob controls the this pump. So what it does, it's mode between only using the interior part or using the whole coil. So it just switches this valve on and off. And this, what it does, it controls the pump. So it's like a regulator of a gas. So if you increase it, the pumps more oil, and it in turn increases the heat exchange between the vessel and the coil. So then this system architecture can be used in varied number of options, like your own a modular cooktop. Maybe you want one hob or two hob, or a rice cooker integrated, or so after these ideations and these concept arrivals, like after this architecture was done, it was realized that the technology is still at its nascent stage. So it might not be 100%. So you would need an alternative reliable source, which is LPG. So a hybrid kind of system in which burner and this system can be integrated was also thought upon. How it can work, like you can give it at the back and give it LPG in the front. So many configurations can be made. So, but after studying Indian kitchens, like we went to Hiranandani, into few kitchens, like, so it was decided that the technology is new, so it will be expensive and it will not be 100% every time. It will improve over time. So, but the early adopters would be the people who have the buying power and who are aware about new sustainable and green practices and want to follow them. So we went to upper middle class and upper class people like in Hiranandani and saw their kitchen. So even in their flats, they have very small kitchens. So, and another system, another cooktop won't be possible. So we then thought upon that this system will be needing an architect, like infrastructure of itself, like copper lines coming and going out of your house. So like, for example, in many of the Mumbai buildings, they are installing LPG connections lines now. So they are like integrating it with the initial infrastructure. But in future, if you can have a dedicated shaft, or you can move these pipelines through the shaft of the house itself, and they can come into your kitchen with an manual override valve, and then you can integrate your single cook stove near the shaft. So we initially, I showed you that we have a pump with our system, but then we also thought that depending upon your height, your floor, like for example, if you're living on 3rd floor or 4th floor, or as compared to living on the top floor. So top floor person will not need much pumping power, because the system is just up on the terrace. But the person living on ground floor and 1st floor would be need more pumping power. So instead, the pump would be separate, because for example, if your system is not efficient, like if the electricity consumption is that much, that system is not efficient, then it's of no use. So depending upon your apartment height, it also depends upon like how much electricity consumption is happening basically. So then for fabrication, like many of the air conditioned people are very good in fabricating and turning copper coils. So you can bend these copper coils in spiral manner, and then flatten it to increase the contact area between the vessel and your copper coil, and then encase it in a insulating thing like a fly ash, which are thermal insulant, like silica, alumina, clay, fly ash, things like that. And then at the bottom, you can see the terminal points of coil can be like this. And then it can come over a stand, and then the pipes, which initially I showed you like hard copper pipes. So the copper pipes will be hard, but the pipes which are used in this cook stove are braided steel pipes, which are insulated and which are flexible, so that you can easily connect it below the at the copper terminals. And then toughened glass surface will come over with interface basically. And then some detailing to prevent spilling of liquid and going liquid inside, like the cross section you can see. So this to prevent spillage and leakage. And yes, then this is the final design. So like in many additions were made, as I showed you, that telescopic copper coil and flexible, which takes the shape of the vessel, all those were made. But in the end, like a basic simple product was made, because the technology is still new and developing, and there are not much kitchen space in kitchen. So when the technology improves, and when the infrastructure can be integrated, then maybe you can design multiple options using the property. So any questions, any comments?
When you say technology, right, what exactly, which part of this product are you referring to? What I wanted to ask.
The technology in terms of when I showed you the sensible heat storage material, and the heat transfer between the coil and the vessel, and the heat flow rate, basically all those variables. I'll just show you that slide at the start. So after research and reading like few papers, so like these 5 points you can see. So these 5 points I took as a designer from the research and after talking to professors. So these were the technical aspects I was talking about. So as you can see, there are many variables. I didn't go very deep into it at that time because it's a like design project, because my professors was also telling at that time that you are doing more of engineering than design. So that was the thing with this project, but that's also why that it is.
So, Mridul, please show your final mala once. Put your slide over there, no?
Yes.
The final offering where, you try to mimic the... You finished the presentation, no?
The final render, actually. This one.
What happened to your product? You didn't show the product.
Model.
Model.
Oh, I couldn't find the model picture, sir. I'm sorry.
Actually, model was pretty good. So again, because we are all discussing semantics and all. So students, for example, you see here, for example, what from our discussion, what do you feel? Let us see from that point of view. Mridul, we just discussing this issue of, is it creating a new semantic that it is an oil, solar, device design?
Sir, honestly, at that time, I didn't think much about the semantics, but at the back of the mind, there was this idea that this product should look friendly and relatable to a kitchen. This product should look like a kitchen stove. So
very true, very true. In fact, see, so students, you notice even we designers tend to go towards training of perception. Kitchen ka product hai, it should belong to the kitchen, right? It should belong to the contemporary modern kitchen. That takes, a larger sort of, weightage over creating a differentiation. Because differentiation is always very risky. Because you're taking the perception away from, the current products. So that's a very big challenge. We'll discuss all that, later on. But, any other questions for me and Mridul?
I had just one question. In terms of the building section, which Mridul showed, what would be the limit? Because I'm sure, in terms of the floor heights, in the section it showed around 4 or 5. But maybe for very high height buildings, then it would be a problem, right? Or maybe you need to have solar panels at different levels to kind of each, like 5. It would be divided in 5 floor sections, and each section would have its own system. Maybe that could be done, right? So
no, these are not solar panels. These are solar concentrators, which are like big, heavy systems, which will be on the roof. There are no other places like Mumbai.
So then that would suffice for 20 floors also, you're saying?
If more people are using it, then the storage tank which stores the vegetable oil, so it will be big. So this system can also be rethought upon in terms of if each flat has their own storage, or there would be a common storage or common pump or a individual pump, how the efficiency will work. Because if a person is living on ground floor, then for him to pump oil up and down 10 floors would be very inefficient.
Yeah.
So students, all these new products, for example, what Mridul has worked may be a reality within 5 years to 10 years. For sure, when the gas prices become, 5,000 per cylinder, and they're going to happen, all those are going to happen in the future. So if the sustainable, aspects will come in more and more. So that's going to happen anyway. But, from point of view of perception, form, development, we always are, got all these challenges of what should be the product, look, what should be, how much it should look like the current gas stove, how much it should look different, just cosmetically color and graphics, will it be enough? Or should we also have, a form factor to it? And today we talk about minimalistic forms like the iPhones and the mobile phones. See, mobile phones don't do anything extra nowadays, right? Very, very simplistic form. So is that valid? Is it the best thing to do? Why are they doing it? That's also, a question for us. Sometimes even the grip is not there. You'd add a lot of add-ons to provide a grip to the mobile phones. Basic function of grip is not there in the phones. You're holding a product in the hand. So even that is not there. So it's quite a challenge. Anyway, we'll discuss that a little later. So so that's the whole point now. So let us have these two things for today, and the assignment for us basically is to look at our Raymond Louis example 1, very close from point of your form and its development for all the projects which is done. Make a short presentation on that. You get that ready, and then the next like we will see some of your presentations right now, what we missed in the morning, some critique on that, and your offer of a semantic differential for a PV stove, those chula, the PV photovoltaic chula. What if you are see, why do all industry people go to design schools to see what students are doing? Because design school, there is less risk for the students to innovate. There's less risk for the students to think, dream new. Whereas the companies, they're always bothered about market, bothered about perception, bothered about things. So you, with that type of situation, can look at new semantic for a terracotta-based chula. Let us see what you think about and how you go about doing that. Maybe you can just work on sketches for the time being, and then we'll discuss those also. And these are the two things you need to do. And then remember, we're talking about one of our most used utensil in the house. Your house most used and your most liked utensil could be a gas cooker. It could be a it could be a it could be a tawa on which you make dosas, or the pan which you make omelets. Please pick up one of those from your home, and don't cheat yourself. The most widely used, we want you to choose the most widely used and keep that with you and study that in detail, one product, and then just show us one good picture of that particular product, and don't hesitate to show us even if it is got really very overused and there are a lot of dents in that. Don't worry about it. We just choose that from your kitchen, the most favorite utensil. Because for example, I have one most favorite utensil which is my chai ka ladle, on which we make tea, because it has got some phenomenal features. But anyway, so you have to choose one from what your mother likes the most, or you like the most, your sister like the most, whichever way, but it should be the most liked utensil in your house, which you're using for cooking purpose. Yeah, so that one. So 3 things for us to do today, and some reading materials. I'll also share one presentation from our senior designer with you. And again, we'll catch up tomorrow. Maybe tomorrow we'll catch up at 10. And thanks, Mridul. Thanks for those 2 wonderful presentations.
Yes, sir. Thank you.